Meet Jupiter, king of the planets. Jupiter isn't just the largest planet in our solar system. It's a world unlike anything we know. More than 11 Earths could fit across its diameter. Over 1,300 Earths could fit inside its volume. Yet despite its size, Jupiter isn't a rocky world. It's a giant sphere of gas and liquid, wrapped in a deep atmosphere thousands of kilometers thick. The scale of the king. Jupiter's sheer size is difficult to comprehend. With a diameter of about 142,984 kilometers, 88,846 miles, Jupiter is roughly 11 times wider than Earth. To visualize this, if Earth were the size of a grape, Jupiter would be about as big as a basketball. In terms of volume, Jupiter is so massive that over 1,300 Earths could fit inside it. Its mass is equally staggering. Jupiter is more than twice as massive as all the other planets in the solar system combined, and 318 times as massive as Earth. A world without a surface. Unlike Earth, Jupiter is a gas giant with no true solid surface. The planet is composed mostly of swirling gases and liquids. A spacecraft would have nowhere to land on Jupiter, and the extreme pressures and temperatures deep inside would crush, melt, and vaporize any probe trying to fly into the planet. Jupiter's composition is primarily hydrogen, about 90%, and helium, about 10%, with minor amounts of methane, ammonia, and other trace gases. The deep atmosphere. Jupiter's atmosphere is the largest planetary atmosphere in the solar system. It features over 20 atmospheric jet streams that penetrate thousands of kilometers into the planet. The visible surface we see is actually the top of its cloud layers, which span about 44 miles, 71 kilometers, in thickness. These clouds form the planet's iconic colorful stripes and bands. The dark orange stripes are called belts, while the lighter bands are called zones, and they flow east and west in opposite directions. Jupiter likely has 3 distinct cloud layers in its atmosphere. Top layer, probably made of ammonia ice. Middle layer, likely made of ammonium hydrosulfide crystals. Innermost layer, may be made of water ice and vapor. The interior, from gas to liquid. As you descend deeper into Jupiter, the immense pressure transforms the atmosphere. The hydrogen gas gradually compresses into liquid hydrogen, and deeper still, into liquid metallic hydrogen. This metallic hydrogen layer is what generates Jupiter's powerful magnetic field, which is 16 to 54 times as powerful as Earth's. Data from NASA's Juno spacecraft suggests that Jupiter's core is not solid but rather fuzzy or partially dissolved, with no clear separation from the metallic hydrogen surrounding it. Extreme conditions. Jupiter experiences extreme temperatures and pressures. At an atmospheric pressure of 1 bar, an arbitrarily defined surface for Jupiter, the average temperature is approximately -110 degrees Celsius -166 degrees Fahrenheit. The planet also has the shortest day in the solar system, taking only about 9.9 hours to spin once on its axis. This rapid rotation contributes to its powerful winds, some reaching up to 539 kilometers per hour, 335 miles per hour, at the equator. A planetary system of its own. Jupiter is so large that it forms a kind of miniature solar system. It has 95 officially recognized moons, including the 4 large Galilean satellites Io, Europa, Ganymede, and Callisto, first observed by Galileo in 1610. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury. Jupiter also has a faint ring system composed of small, dark particles, discovered by NASA's Voyager 1 spacecraft in 1979. Imagine a storm so vast that our entire planet could fit inside it. Not for a day, not for a year, but for centuries. Deep within the turbulent atmosphere of Jupiter, a colossal storm known as the Great Red Spot has been raging longer than any nation on Earth has existed. It is one of the greatest mysteries in our solar system. What is the Great Red Spot? The Great Red Spot is a persistent, high-pressure region in Jupiter's atmosphere that produces the largest anticyclonic storm in the solar system. Unlike a hurricane on Earth, which is a low-pressure system, a cyclone, the Great Red Spot is a high-pressure system, an anticyclone. This means the winds circulate in the opposite direction. On Earth, a hurricane's winds spiral inward toward a low-pressure center. On Jupiter, the winds spiral outward around a high-pressure center. Scale and power. The sheer size of the Great Red Spot is its most staggering feature. It is so large that Earth could easily fit inside it. While its size has been shrinking over the past century, it is still roughly 1.3 times the diameter of Earth, measuring about 16,350 kilometers, 10,159 miles, across. To put that in perspective, the most powerful hurricanes on Earth might span 1,000 miles across, but the Great Red Spot is more than 10 times that width. The storm's power is equally immense. Winds inside the Great Red Spot scream at speeds of up to 496 kilometers per hour, 308 miles per hour. This is far more violent than any hurricane ever recorded on Earth. Longevity and mystery. The most profound mystery is the storm's incredible longevity. It has been raging for centuries, far longer than any single storm on Earth could ever last. While it was first observed in its current form in 1831, a similar spot was observed as early as 1665, meaning the storm could be over 360 years old. On Earth, hurricanes dissipate within a few weeks because they lose their energy source over land or cooler water. Jupiter, however, is a gas giant with no solid surface to weaken the storm. The Great Red Spot also draws energy from Jupiter's atmosphere, partly by absorbing smaller storms that drift into it, and it sits wedged between two opposing jet streams that keep it locked at a specific latitude. A changing storm. The Great Red Spot is not a static feature, it is constantly changing. Observations show that it is shrinking. In the late 1800s, it was about 25,500 miles across, but it has now shrunk to approximately 10,250 miles across. Its shape is also changing from an oval to a more circular form. Furthermore, the storm jiggles like gelatin, oscillating in size over a 90-day period. The cause of its iconic red color also remains a mystery, though it is thought to be due to complex chemical reactions in Jupiter's upper atmosphere. For centuries, astronomers noticed something strange. A massive red oval embedded in Jupiter's southern hemisphere. Some observations may date back to the 1600s. Generation after generation looked through increasingly powerful telescopes and found the same thing. The storm was still there. A discovery spanning centuries. The story of the Great Red Spot begins in the 17th century. The English physicist Robert Hooke first reported seeing a large oval-shaped feature in the southern hemisphere of Jupiter in 1664. The following year, in 1665, the Italian astronomer Gian Domenico Cassini observed what he called an exceptional spot, which he referred to as the Big Permanent Spot. Cassini's observations were particularly significant. He used the spot's movement across Jupiter to determine the planet's rotation period, calculating it to be about 9 hours and 56 minutes. However, there is a puzzling gap in the historical record. While Cassini and others observed a similar spot from 1665 to 1713, no observations of such a feature were recorded between 1713 and 1830. This has led to debate among astronomers. Is the Great Red Spot we see today the same storm observed centuries ago, or did the original spot dissipate and a new one form later? If it is the same storm, it has existed for at least 361 years. Continuous observation since the 1800s. The modern era of Great Red Spot observation began in 1831, when it was first observed in its current form. From 1831 to 1878, over 60 recorded observations were made, and since 1878, the storm has been continuously monitored. An illustration depicting a red spot on Jupiter similar to the modern feature appeared in 1831, and the spot was rediscovered by American astronomer C.W. Pritchett in 1878. What astronomers have learned. Through centuries of observation, astronomers have determined that the Great Red Spot is a persistent, high-pressure region in Jupiter's atmosphere, producing the largest anticyclonic storm in the solar system. Located 22 degrees south of Jupiter's equator, it produces wind speeds up to 496 kilometers per hour, 308 miles per hour. Unlike a low-pressure hurricane on Earth, the red spot rotates counterclockwise in the southern hemisphere, indicating it is a high-pressure system. The storm has been shrinking over time. In the late 1800s, it was large enough to fit 3 Earths within it, but today it measures about 1.3 times the diameter of Earth. Recent observations from NASA's Hubble Space Telescope have also revealed that the Great Red Spot jiggles like a bowl of gelatin, oscillating in size and shape over a 90-day period. The Great Red Spot's size compared to Earth. The Great Red Spot is a massive anticyclonic storm in Jupiter's southern hemisphere, and its size has been a subject of fascination for centuries. To understand its scale, it helps to compare it directly to Earth. Earth's diameter is approximately 12,756 kilometers, 7,926 miles, at the equator. This is the standard measurement used for comparison. Today's Great Red Spot measures roughly 16,350 kilometers, 10,159 miles, across, according to NASA. This means the storm is about 1.3 times the width of Earth. As one source notes, the storm is large enough to engulf Earth. Even at its current, reduced size, you could place Earth inside the storm with room to spare. The storm at its peak. The Great Red Spot was once far more enormous. Historical observations from the late 19th century, specifically around 1879, measured the storm's long axis at approximately 39,000 kilometers, 24,200 miles. Other sources from the same era estimate it was about 41,000 kilometers, 25,500 miles, across. To put that in perspective, at 39,000 to 41,000 kilometers wide, the storm was roughly 3 times the width of Earth. This means you could line up 3 Earths side by side across the storm's longest dimension. Why Earth's hurricanes die? On Earth, hurricanes are fueled by warm ocean water. They require evaporation from the sea surface to survive, extracting heat and moisture from the ocean. Once a hurricane makes landfall, it is cut off from this energy source. The roughness of land terrain increases friction, which further slows the storm's winds. As a result, sustained winds in a hurricane decrease at a relatively constant rate, approximately half the wind speed in the first 24 hours after reaching land. Even if a hurricane remains over the ocean, it will weaken if it moves over cooler water, as it loses access to the warm surface temperatures that power it. Why Jupiter's storms last for centuries? Jupiter's Great Red Spot, in contrast, has persisted for at least 150 years and possibly much longer. The key difference is that Jupiter is a gas giant with no solid surface. Because there is no land to create friction or slow the storm down, Jovian winds and hurricanes can last for centuries, if not longer. The Great Red Spot is fueled by Jupiter's rapid rotation and the heat radiated from the planet's interior, not by ocean heat. Additionally, vertical flows within the storm help sustain it. When the storm loses energy, these vertical movements replenish it. Jupiter's storms can also merge, combining to form even larger oval features, and bigger storms like the Great Red Spot can gobble up smaller neighbors. Then contrast. Jupiter has no continents, no mountains, no coastlines, nothing to stop the storm. This contrast is the fundamental reason why Jupiter's Great Red Spot has endured for centuries while Earth's hurricanes dissipate in days or weeks. On Earth, hurricanes are quickly destroyed by physical barriers. They weaken rapidly over land, which cuts them off from the moisture and heat of the tropical ocean. The roughness of land terrain increases friction, and once over land, the system is cut off from its heat and moisture sources. Even over the ocean, hurricanes weaken when they move over cooler water. Earth's geography, continents, mountains, and coastlines acts as a natural brake on every storm. Jupiter has none of these obstacles. Because Jupiter lacks a surface that slows or confines storms, Jovian winds and hurricanes last for centuries, if not longer. The planet is a gas giant with no solid surface to impose boundary layer friction. There are no continents to block the storm's path, no mountains to disrupt its circulation, and no coastlines to cut off its energy supply. The Great Red Spot simply swirls in the atmosphere, unimpeded by any physical barrier. Furthermore, Jupiter's environment actively sustains the storm. The Great Red Spot is driven by the transfer of heat from a hotter region to a cooler region of the planet. When the storm loses energy, vertical flows move to replenish it. The storm also feeds on smaller vortices, absorbing them to maintain its strength. As one source notes, bigger storms like the Great Red Spot gobble up smaller neighbors. The result is a storm system that has persisted for at least 190 years, and possibly much longer. While Earth's hurricanes are fleeting events measured in days, Jupiter's Great Red Spot is a permanent feature of the planet's atmosphere, a direct consequence of a world with no land to stop it. The king of the planets. Somewhere in the darkness of space, a storm larger than Earth continues to spin. It has survived kings and empires. It was already raging before the Industrial Revolution. It may still be there long after we are gone. This poetic description captures the extraordinary longevity and scale of Jupiter's Great Red Spot. The storm is a persistent, high-pressure anticyclone in Jupiter's atmosphere, and it is the largest storm in the solar system. It is wide enough to engulf Earth, measuring approximately 16,350 kilometers, 10,159 miles across. The storm has been observed continuously since 1831, making it at least about 190 years old. This means it was already raging long before the Industrial Revolution, which began in the mid-18th century. It has indeed survived the rise and fall of kings and empires, having been present through the Victorian era, both world wars, and the entire modern age. While the storm has been shrinking over the past century, from a long axis of about 39,000 kilometers in 1879 to roughly 14,000 kilometers today, it remains a formidable feature. Its persistence is due to Jupiter's lack of a solid surface, which means there are no continents, mountains, or coastlines to slow it down or break it apart. The storm is also sustained by the planet's internal heat and its own dynamics, feeding on smaller storms to maintain its energy. The question of whether it will outlast humanity remains open. Some researchers suggest that if the current shrinking trend continues, the Great Red Spot could eventually break up, possibly within the lifetimes of people alive today. However, this is a possibility, not a certainty. For now, the storm continues to spin, a testament to the enduring power of nature on a world far different from our own. Thank you for watching.